Hi, welcome back to Unit 5 Day 9 practice. This is example 4. So let's dive into it, shall we? We're predicting our products. First thing we're going to do is we're going to start with our reactants, break them down into anions and cations. The cations will be metals or NH4+, and that's what's written first. So that's my first cation. And what's written second, the nonmetals, will be your anion. That's my anion there for that reactant. We'll do it again for the second reactant. Cation, of course, is the metal that's written first, and then the anion will be the nonmetals that are written second. We do this so that we know which partners that we're switching, right? So we're switching our cations and anions together to make new products. Okay, so on the product side, I am going to switch my first and my last. So ZN switches and CO3. That's my compound. I'm leaving a little space in case I need to write some subscripts in to balance the product, or write the correct formula for the product. Then we're going to do the inner ones, but the key thing about this one is that the metal or the cation has to go first. So it's going to be NaNO3. Okay, so now I need to check this formula to make sure if it's correct or not. And when checking the formula, I look at the charges for a transition metal like zinc. Typically for transition metals, you have to figure it out. Zinc actually has a common charge, but most transition metals don't. So let's say you didn't know that zinc has a common charge of +2. How would you figure that out? You would go back to your chemical formula of your reactant. So zinc is in this reactant here, and the overall charge of this ionic compound must equal to 0. So I figure out what's the charge of my nitrate. Nitrate has a -1 charge. Here we go. So nitrate has a -1 charge. And I have 2 of them. And I know I have 2 nitrates because there are 2 outside the parentheses of the nitrate. So that means I have 2 of these nitrates. So that means that the overall charge from the anion is going to be -2. So now I need to figure out, well, what must the charge of zinc be? So what plus -2 will give me 0? And since I have only 1 zinc, the answer to that will be +2. So I know that the charge on the zinc is going to be +2. Okay, so that part's done. Now I need to figure out, again, I'm just checking to make sure this formula is correct. So to figure out if the carbonate CO3 is correct, what I'm going to do is I'm going to go on this table here, find my carbonate, CO3 2-. The charge of carbonate is -2. These 2 charges, when you add them together, will equal 0. +2 and -2 add together give you 0, so that's the right formula. Let's do the same thing with the next one, sodium nitrate. So I start with my metal. Sodium is a group 1 metal. And it's helpful to know what your group 1 and group 2 metals are, and also the charge on aluminum, because then you don't have to, spend so much time finding them in the periodic table. So if you know that sodium is in group 1, it really does help you out. All right, so sodium is in group 1, +1. So it has a +1 common charge. And then my nitrate polyatomic ions, for these, I have to look on this polyatomic ion chart. Remember, polyatomic ions are made up of more than 1 atom. So NO3 is made up of more than 1 atom. So I'm going to go over here, and nitrate has a -1 charge. All right, so then these formulas are also balanced. So these are my 2 products, okay? All right, so far we've been on a winning streak of not having to change the formulas. That streak is about to run out. So in the next video, you'll see an example where we do have to manipulate and correct the formulas of our products.